Today we're going to explore caffeine, and here is a photo of a microscopic view of the caffeine crystals. Caffeine exists by itself as a solid in the form of a white odorless powder, and these crystals appear to be very fibrous. The components of caffeine are carbon, hydrogen, nitrogen, and oxygen. And caffeine is an organic molecule, which means that it exists in living systems. It comes from plants and obviously interacts with the human body in a lot of different ways. We can see that the components of caffeine are mostly all in the same period. We have carbon, nitrogen, and oxygen here, and hydrogen over here. All of these elements are nonmetals. So to find the moles in an average cup of coffee, I did the average cup of coffee as 8 ounces or 240 milliliters. And a cup of coffee generally has anywhere from 65 milligrams of caffeine to 200 milligrams of caffeine. So 100 is a good number to work with and close to the middle of that. And so we end up with the concentration of caffeine per this 8-ounce cup of coffee being very small at 0.002 molar. The geometry of caffeine is dependent largely on the sp2 hybridized points of these carbons here and the nitrogens that make up this ring. And so this is kind of what it looks like in a more 3D way. These are the bonds, and those are sigma bonds. This is from the top view. And on the side view here, we have multiple pi bonds. Caffeine is classified in a few different ways, and these kind of go in descending order from the largest classification to the smallest. The largest classification is an alkaloid, and alkaloids tend to be pretty dramatic compounds. Morphine is also an alkaloid. Most chemicals ending in the name INE or ene are going to be alkaloids. And then the methylxanthines, and finally the purines. And caffeine is a central nervous system, cardiac, and respiratory stimulant. And some other examples of purines include epinephrine and the DNA nitrogenous bases adenine and guanine. Caffeine comes from multiple different plants, mostly associated with Asia and South America. The coffee plant is a South American plant, and the precursor compounds in this plant are the methylxanthine, then theobromine, and that happens throughout the plant's life cycle, probably due to the enzyme activity in the plants. There's also a high phenolic antioxidant content in the coffee plant, and when purines are metabolized, one of the byproducts is called allantoin, and that is known to be a cell proliferant. One ways that caffeine participates in a precipitation reaction is with tannic acid, and this is a basic acid-base reaction, and it's the caffeine that's slightly basic and the tannin is slightly acidic. The positive nitrogen here on the caffeine is going to interact with one of these hydroxyl groups, one of the hydrogens on the hydroxyl groups, and that's going to have an electrostatic relationship resulting in a covalent bond between the hydrogen here and the nitrogen right here. How much the tannin actually does precipitate the caffeine is going to depend on a lot of different factors. It doesn't necessarily happen in a cup of coffee, and so that's some of those factors are going to include the pH of the solution, the temperature, the polarity, if anything's added to coffee, such as a fat like coconut oil or an alcohol like whiskey, that's obviously going to change the relationship between the tannic acid and the caffeine. And a lot of people have been concerned about what that precipitation results in. Some people have been concerned about cancer causing products of that reaction, but the Cancer Council of Australia and multiple other organizations have done studies showing that caffeine is actually not cancerous or carcinogenic at all. And there are actually very small amounts of caffeine or of the tannins compared to caffeine in a cup of coffee. One study published by the National Center for Biotechnology Information averaged about 17.5 milligrams per gram of coffee bean of the tannic acid, which calculates to a molarity. If you used 1 gram of coffee beans per 8 ounces of water for a cup of coffee, the molarity of that would be 0.0004. So much smaller amounts than the caffeine, and most likely apparently not harmful. And decaffeination is actually usually done with other chemicals such as dichloromethane. That concludes this presentation of some basic concepts we studied in the Chem 240 class and regarding caffeine specifically.